All right, so we're going to use mathematical induction to derive this formula here for all n bigger than or equal to 1. So proof by PMI. We're going to do our base step. We're going to consider P of 1. So that's 1 times 1 factorial. Has to be equal to, well, is equal to 1, right? And then we'll do the 1 plus 1 factorial minus 1, which is 2 factorial minus 1. 2 factorial is 2, and 2 minus 1 is 1. So that checks. Let's go ahead and consider P of 2, right? So that's 1 times 1 factorial plus 2 times 2 factorial. And that's equal to, we've already established that's 1 plus 2 times 2 factorial is 2. So this would be 5. So let's look at 2 plus 1 factorial minus 1. 2 plus 1 factorial is 3 factorial minus 1. 3 factorial is 6. 6 minus 1 equals 5. So that works too. So let's go ahead and do our induction step. So we're going to suppose P of k is true. P of k is true. Thus, we have a 1 times 1 factorial plus 2 times 2 factorial plus 3 times 3 factorial plus dot 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 plus k times k factorial is equal to k plus 1 factorial minus 1. Okay? So, now consider 1 times 1 factorial plus 2 times 2 factorial plus dot 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 plus k times k factorial plus k plus 1 times k plus 1 factorial. Now, from here, right, from our induction step, we know this sum is equal to k plus 1 factorial minus 1. And then we're going to add that plus k plus 1 times k plus 1 factorial. And I can see I can factor out a k plus 1 factorial from these two terms. So if I do that, k plus 1 factorial, I'm going to be left with 1 plus, and then that k plus 1, and then I'm going to have that minus 1 out here, right? And then this is equal to k plus 1 factorial times k plus 2 minus 1. And of course, k plus 1 factorial times k plus 2 is the same thing as k plus 2 factorial. And then to make it exactly the way we want, this is the same thing as k plus 1 factorial minus 1. So we're able to show that assuming that this sum is equal to k plus 1 factorial minus 1, we're able to show that the sum up to the k plus 1 term is equal to the formula if you plug in k plus 1. Right? 1 factorial plus 2 times 2 factorial plus dot 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 plus k times k factorial plus k plus 1 times k plus 1 factorial is equal to k plus 1 factorial minus 1. Okay? Therefore, by PMI, for every n, that's a positive integer, right? We know 1 times 1 factorial plus 2 times 2 factorial plus dot 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 plus n times n factorial is equal to n plus 1 factorial minus 1.